The three examples included in this problem are really a part 2, as we predicted the products for these in a previous practice problem. This is by design, as it's exceptionally likely that you'll have to go all the way from just the two reactants to the net ionic equation. Sometime before the quiz, it would be a good idea for you to redo these from scratch, moving all the way from the reactant salts to the net ionic equation without using any notes. Since we started these earlier, I went ahead and included all of the intermediate steps to get from the reactants to the products. If you started this over and didn't come up with these as your products, pause the video now and see if you can follow my process. When you get to this step in white, review your products and identify the important product if there is one. And there is here, since the reaction forms a solid, which is nickel carbonate. Include the cation and the anion that comprise this salt as reactants, and the salt itself as your products. Next up is the net ionic equation between lithium chloride and lead 2. After a fair amount of effort earlier, we made it to this point. This reaction results in solid lead 2 chloride, which is comprised of the lead cation and the chloride anions. Our net ionic equation is therefore this. Note that the atoms and the charges are both balanced and that states of matter are included in my equation. Lastly, let's write the net ionic equation for the reaction of silver nitrate and sodium perchlorate. Here, when we review our reaction in hopes of an important product, we don't see one. Everything here is aqueous. That means that we started with a bunch of ions floating in solution, and then after we mixed those ions, we're still floating in solution. Nothing changed chemically. I have the same chemical species now that I did before. I've essentially just moved them from one place to another. So everything on the reactant side is identical to something on the product side, and they will all just cancel across that reaction arrow. When this happens, and it will fairly often, the correct answer for the net ionic equation is really just that there isn't one. You will include the phrase "no reaction" in these scenarios.